Okay, number 37. Colin noticed that the various combinations of nickels and dimes could add up to 65 cents. Let x equal the number of nickels and let y equal the number of dimes. What is the domain where y is a function of x and the total value is 65 cents? Well, the word domain tells us all the x values. So that means we're just looking for the number of nickels. That's what the question is asking for. How many, or what are the possibilities for nickels? Well, I know nickels are going to be like 5, 10, 15, 20. And I know that the total value ends in a 5. So if we only had dimes, could we get 65 cents? No, so we at least need one nickel. So I know one's a possibility. And if we only had two nickels adds up to 10 cents. That's not giving us our 5 there. So it can't be 2. Could it be 3 nickels? Yeah, that's 15 cents. That ends in a 5. This ends in a 5. So really, do you see the pattern? We're just looking for all the odd numbers for nickels. Because the evens won't work because that gives us a multiple of 10 there, like 10 cents, 20 cents if we use even numbers. So two nickels is 10 cents, 4 nickels is 20. So I can eliminate answer choice A because they had the even number 2 in there, they had 0 in there, so that's not possible. Look at B, it has 2 in there and 4 in there, that's not possible. C has the 1, 3, 5, 7, 9, so they did keep the pattern that we found out. However, they included 0. It can't have 0 in it, because if you had 0 nickels, you could either have 60 cents or 70 cents if you just used dimes. Alright, let's look at D. D was smarter, they got rid of the 0, and 13 would be 65 cents, so 13 times 0.05. So this one checks out. So D it is. And be careful because if they were asking for the range, we would have been looking for the, you guessed it, the Y values. That would be our range, which would have been the number of dimes. So read it carefully. Okay, number 38, the value of an antique car is modeled by the function v of x equals 107,000 parentheses 1.09 to the 2 to the thirds x power. And it says x is the number of years since 2005. What is the approximate percent rate that the value of the car is increasing per year? Well, I know that this is a growth, and the reason I know it's a growth, number 1, they told me. Number 2, I know that that number in parentheses is greater than 1, and I know it's 0.9%, but this says per year, so I know that that only works if it's to the x power. So this must be to the nt power, and remember that because this is being compounded, so the n is the number of times that it is compounded per year, and the t represents the number of time periods. So since this is getting a little tricky since it's compounding, and I know I have a calculator, so what I'm going to do is just type that function in and y equals. So go to your calculator, type in y equals, it's the top left button, do 107,000. Just type it in exactly as you see it, 1.009, and then you're going to use the caret symbol. That gives you your exponent. And just make sure that that you do 2/3 in parentheses when you do that. So it's 2/3 times x. And if you have a calculator like mine, where it doesn't actually raise it up visibly, you're going to want to do parentheses around the whole thing, just like that. So parentheses, parentheses, 2 divided by 3, close the parentheses, and then x, and then close the parentheses. Alright, so type that in, and then hit second graph, and you can see the table of values and see how it's changing for each year. And after I hit second graph, here's what I get. So after 1 year, it's 107,641. After 2 years, 3 years, and 4 years. Does your table match mine? I hope so. If not, type it in again. Next up, we can do the amount of change over the original to find out how much it's increasing per year. Again, that formula is the amount of change over the original, and that's going to give us our percent of change. In this case, a percent of increase. So I'm just going to use from year 1 and year 2 since they're in my table. So to find the amount of change, I'm just going to subtract those two numbers. Just take the bigger number, subtract the smaller number from it. And it should look like that. And your original number is going to be, what did you start with? Well, we started with year 1 and then we jumped to year 2. So year 1 is going to be my original amount. So subtract that top part and then divide it. And I got 0.00599, and that's a decimal, so to make it a percent, that's right, we move it 2 spots to the right. So it's really 0.599, which is essentially 0.6% if we round it. So it looks like answer choice C is going to be our best bet right there. So again, this one was tricky, remember, because it had not just to the x power, it had to the 2/3 x, and that 2/3 tells us it's being compounded. So if they put 0.9% in there, you may have been willing to choose it. They didn't put that in there, but if they did, you may have been tempted to make that choice. So don't fall into that temptation because it's being compounded. You can't treat it like that. And if you have extra time on the test, you can go back and just check from year 2 to 3 if you do the amount of change, so that number minus that number, and then divide it by your original number 108,286. And I just did it in my calculator. I got the same thing, 0.00599, same thing we got before. So it should work for every one of those calculations. All right? All right, I hope you keep learning something. I'm going to go ahead for a stroll in my nice antique car.